So now what I want to do is continue on with these and talk about an idea that is, it's a tool that you can use to break down numbers that is effective and fast and very good. I call it Diviso. What it really is, its correct mathematical definition is the rules of divisibility. All right, so Diviso is short for the rules of divisibility. There are certain rules of mathematics that are true that we found over the course of working with mathematics that you can use to break down almost any number. So some of these numbers are 2, 3, 5, and 3, 2, 5, and 10. There are additional diviso numbers or rules of divisibility numbers or rules of divisibility that can be applied here. I only use these numbers and because I think it's simpler for students to understand. And for many of the other numbers, in a sense, these are factors of those larger numbers. So that's the reason why I only use these four numbers, 2, 3, 5, and 10. I also talk about what I call the 7-11 exception rule, and we'll get to that a little further. So, many students, when looking at 86 and would have got the 2 and the 43, would have kept on trying a whole bunch of different ways to see if, there's got to be something small, it's got to be something smaller. But if you learn to understand the rules of divisibility, you'll find out I was able to quickly and confidently break this down just by knowing these rules. So what I'm going to do now is I'm going to finish up laying out the prime factorization of these numbers and talk about how we can rip down these numbers faster and quicker using the rules of divisibility, or what I like to call Diviso. So let me finish this prime factorization out. So we'll go over here. Now what I want to do is, since I've laid out all my prime factors and circled them to make them easy to see, and I want to lay them out to let anyone see what prime numbers comprise this multiple here. So we go down here. I have 1, 2, 3 2s. I can do it this way, 2 times 2 times 2. I'm a little too lazy for that, and so are most mathematicians. So what we like to do is go 2 to the third power. That lets us know, and you know that, just put down 2 3s like we did here initially, and you'll find the answer. So in a sense, exponents are shorthand and sort of the easier way. So we'll go over here, and if I need to, I'll slash through these, just so I don't make the mistake of going back and counting them or whatever, particularly when you get to numbers where there are a lot of different prime factors involved. So we'll go here. You notice I have one more 3. So the prime factorization of 24 is going to be 1, 2, 3 2s, so 2 to the third power, meaning that 3 sets of 2, times 3. Well, let's do a check. See if that's true. I'll go here. I'm going to leave the 24 so we'll see the original number. I have how many 2s? 3. So 1, 2, 3. And how many 3s? 1. So I'll go here. Well, the product of 2 and 2, 4. The product of 2 and 4, 8. And the product of 3 and 4, 24. So it looks pretty good, and let's look at it's correct in the situation that the prime factorization of 24 is 2 to the third power times 3. So now let's take a look at this one here, and then we'll get into the world of Diviso, or the rules of divisibility. So I'm going to take this 86 and move it over. So 86. And I'll put its factors with it here. We had a 2. We had a 43. It's pretty obvious that that's the true answer. I'm not going to go back and lay down the 2 times the 43 because you can see that there. Let me erase this. So what I'm going to do is I'm going to put the rules of divisibility up here. Where should I put them? Actually, I'm going to put them down here. So let me erase this. Let's go here. And Diviso. Or rules of So rules of divisibility. So some basic rules. Remember the numbers I talked to you about were 2, 3, 5, and 10. There are other numbers you can use for rules of divisibility. I keep it to a limited amount because many of those other numbers are actually multiples of these numbers, and they are factors of those larger numbers. So we'll go over here. The rule is that for 2, you can divide any number that ends in an even number. Ends in an even number. Let's get an example of that. 202, even number. I can divide evenly by 2. 1,208, even number. I can divide that by 2. I don't know. Let's try 122. Notice once again, even number. Or 60. Ends in 0. These type of numbers, any number that you run into that ends in an even number or 0, we could divide by 2. So we can immediately start doing our prime factorization, yada yada, by using that number. Well, I know you're saying, well, that's kind of simple. I knew that, and I understand. So we're going to push on to where things get a little more challenging. So let's take the 3 now. We covered the 2. Let's take care of the situation we had at 3. This number here is probably one of the most powerful tools that you'll have to understand, or not to understand, but to quickly figure out if a number can be divided evenly by, or can be, I guess, factored out properly, or factored out at all, if it is prime or not. This number here. So let's take a look at 3. Let's take a number that seems really awkward. Let's say 111. Can I do prime factorization on that one? That becomes really challenging to a lot of students because they don't know what number should I divide this by. It doesn't have your typical things where it's like 110. Oh, I can divide that by 2. Or 115. I can divide it by 5. Or, so you can see these are pretty simple things here. So with these type of numbers, or any numbers where you're not sure which number to go ahead and start doing prime factorization with, what I want you to do is, I want you to go ahead and try this rule here. And the rule is that anytime I can add the digits of the numbers together, and the sum of those digits give me a number I can divide evenly by 3, 3 is a factor of that number. What does that mean? That means that you can do prime factorization of this number where other people would have been confused. So let's take a look here. Most students, if you say find the prime factorization, they're going to spend a lot of time being nervous about it. You'll quickly look at it and say, hey, I can get the sum of that. That's 3. I can divide this by 3. So let's go ahead and put that 3 to test. All right. We go over here. How many sets of 3 can go into 1? None. How many sets of 3 can go into 11? 3 sets. 3 times 3, 9. I find the difference by taking from the hundreds place value over to the tens. It's going to be 11, so I go 2 here. And then I bring down that value because there's no sets of 3 that can go into 2. Bring down the 1. Then I ask myself, how many sets of 3 are there in 21? There are 7 sets. So you can see in a situation, the product of 7 and 3 is 21. You can see in this situation that actually, if I was asked to do prime factorization of 111, it would be 3 times 37. For many students, this is challenging. What I'm going to do is I'm going to come back and show you some more videos using this and give you some prime situations where you can use this tool effectively to get through problems really fast, take care of the business while other students struggle.